Welcome to The Explainer. Today we're diving into something called single-point theory. It's a really fascinating idea that tries to give us a much more elegant, kind of unified way of looking at reality itself.
Okay, let's kick things off with a bit of a riddle. What on earth could a perfect number from pure math, a super stable atom from physics, and a massive hurricane from meteorology, what could they possibly have in common? I mean, at first glance, absolutely nothing, right? But stick with me, because single-point theory suggests they're all just different flavors of the exact same fundamental pattern.
So first up, you've got this thing called a perfect number. It's a neat little math concept. Basically, it's any whole number that's the perfect sum of all the numbers that divide into it. You see, 28 here, its divisors are 1, 2, 4, 7, and 14. You add this up, boom, you get 28. It's this complete, perfectly balanced, self-contained little system. Just pure mathematical harmony.
Then we've got the hydrogen atom. I mean, this is the bedrock of all of chemistry. It's the simplest atom, and it is remarkably, almost unbelievably stable. We understand the physics behind it with such incredible precision that it's become the ultimate testing ground for our biggest ideas about the universe.
And finally, the hurricane. You think of raw, chaotic power, right? But out of all that chaos, this amazingly coherent and persistent structure emerges. You know, the iconic eye, the spiral arms. It's a stable pattern that can hold itself together for weeks on end, against all odds.
So what is the secret connection? What's the thread that ties a number, an atom, and a storm together? Well, according to single-point theory, it all comes down to one simple, powerful idea: the vortex. The theory basically says that persistence, how a pattern manages to hold itself together, is the real key to understanding pretty much everything.
So let's break that down. Single-point theory, we'll call it SPT, has this really cool take. It says that particles, the fundamental building blocks of stuff, they aren't tiny little solid balls. No, instead, they're more like stable, self-sustaining whirlpools in some kind of universal field. And the center of that whirlpool, it's not some point of infinite density. It's actually a point of perfect stillness, zero energy, defined by this perfect little twist in the field around it. It's literally the calm eye at the center of the storm.
So how do you build a universe from that? Well, the model says it happens in 3 basic steps. First, imagine a fundamental vibration happening at what's called the Planck frequency. That's the fastest anything can possibly vibrate. Second, this insane vibration creates a universal process field that fills, well, everything. And then step 3. Within this field, stable little twists or knots can form. These are what physicists call topological defects, and SPT says these persistent vortices are what we actually see and call fundamental particles.
Now, that is a beautiful, elegant idea for sure, but in science, it's not enough to just be pretty. A theory has to make predictions. It has to be testable against the real world. So, the big question is, how does it actually hold up? To find out, we can take this vortex idea and aim it right at the gold standard of modern physics, the hydrogen atom. Like we said, scientists have measured this thing to an almost unbelievable level of precision. So using what's called the hyperbolic vortex model, which comes right out of SPT, we can stop thinking of the electron as a tiny dot orbiting the proton and start thinking of it as a stable vortex structure.
And wow, check out the results. They're pretty compelling. Just look at this table. The key numbers, like the binding energy and the orbital frequency, the predictions from the vortex model match the official hard data from NIST, well, almost perfectly. We're talking an exact match on frequency and a deviation so small on energy it's almost non-existent. This isn't just in the ballpark. This is the kind of precision that makes you sit up and pay attention.
Okay, so nailing the hydrogen atom is a huge deal, no question. But the real potential of a theory like this is so much bigger. It offers a way to unify our thinking, to connect dots between fields that we always thought were totally separate.
I mean, just think about this for a second. The same core principles of vortex stability could apply across these ridiculously different scales. We're talking about a tornado, a weather pattern you can see from space, and a proton, which is trapped inside the nucleus of an atom. SPT suggests there's a single common language, this cohesion metric, that can describe why both of these things either hold together or fall apart. It's kind of mind-blowing.
And this brings us all the way back to our very first puzzle piece, that perfect number. From this perspective, it's not just a mathematical curiosity anymore. It becomes a perfect abstract example of what SPT calls resonance. You can think of it like a musical chord. All the subharmonics, the divisors, they all add up perfectly to create one single, stable, coherent whole.
So, explaining what we already know is great. But the true test of a theory, the thing that really pushes science forward, is when it makes new predictions. It has to point to things we haven't seen yet, and even better, make predictions that are different from what our current theories say.
An SPT makes some seriously bold predictions. For example, it suggests that certain energy levels in heavy atoms should look a bit different from what our best theory of light and matter, QED, predicts. And then there's the really big one. It suggests that the weird way galaxies rotate, it might not be because of some invisible dark matter at all. It might just be the result of a large-scale vortex structure twisting space-time itself. Now, every single one of these is a concrete claim that scientists can actually go out and test, putting the whole theory right on the line.
So, at the end of the day, single-point theory gives us a new way to look at the universe, not as a jumble of separate, disconnected rules for math, physics, and nature, but as one single, coherent system that's all humming together. And it leaves us with this really incredible thought to chew on. What if everything we see, from a perfect number to a stable atom, all the way up to the swirl of a galaxy, what if it's all just a different note in a grand cosmic symphony of resonance?